So question 6 says, let the function g map from reals to reals such that g of x has the rule a minus x squared, where a is a real constant. The average value of g on the interval -1 to 1 is 31 on 12. Find all possible values of a. So what we need to do here is remember that the average value, so average value of a function is equal to 1 on b take a from a to b of the function dx. So we take the integral of the function between the two values and divide off by the length of the region that we are finding the average value between. Therefore, we can say that our average value of 31 on 12 is equal to 1 divided by 1 take 1 between -1 and 1 of the function a minus x squared dx. So what we can do now is you could either remember how to derive, how to integrate a linear function raised to a power, or we could just expand that. So we could say, therefore, the 1 on 1 minus 1 is 1 on 2 between -1 and 1 of a squared minus 2ax plus x squared dx equals 31 on 12. So all I've done is I've just expanded that bracket, and that's given me these three terms here. So now we can work out what the derivative of that is. So we'd say that's equal to a half, and here it's a squared, so we add an x term onto that as we anti-differentiate, and here we have minus 2ax, so we have minus 2ax squared now, and divide by the original power, by the new power, 2. So technically that would be divided by 1 for the first term, so I've just left that out, but I can put it in there if it makes it a little bit easier to follow along. And then we plus on x to the power of 3 divided by the new power, and we say that that's now equal to 31 on 12. So now I'll just grab a little bit more writing space, and before I do, I better just remember to put in my terminals here. So we're still going from -1 to 1 of this anti-derived function. So I'll just grab a little bit more space. So now we can say that from before we had a half outside of a squared times x minus, so we had 2ax squared on 2, which is just minus ax squared, and then we had plus x cubed on 3 between -1 and 1 equaled 31 on 12. So next up, I think I'll just multiply across the half as well. So if I multiply both sides by 2, that half will disappear, and we can write that as just being 31 on 6, just to save myself a bit of writing space. And now we've got to unpack this here. So what I'm going to do is I'm going to substitute in the 1 to this full equation. So the first thing I'm going to do in the blue is I'm going to substitute that into this function. So I'm going to have a squared times 1 minus a times 1 squared plus 1 to the power of 3 over 3. Next, I'm going to subtract off the green, the -1, multiplied into the anti-differentiated function. So I'm going to subtract off a squared times -1 minus a times negative 1 squared plus negative 1 to the power of 3 on 3, and then that's all still equal to 31 on 6. So if we go through, we can simplify this down. So a squared times 1 is just a squared minus a plus a third. And then from that, I'm going to subtract away a squared times negative 1, which is negative a squared, minus a times negative 1 to the power of 2 is just 1. So if I go through here, that's just equal to 1, and that's just equal to negative 1. So I'm going to have negative a squared minus a minus 1/3 equals 31 on 6. So now take a bit more cleaning up, but we'd end up with 2a squared, because we'd have here a squared, and that's going to become plus a squared. So my next line, I'm going to have 2a squared. My first one has a negative a, my second one gives a positive a, which is no a's, and I have plus a third minus 1/3, which will give me plus 2 on 3 to equal 31 on 6. So therefore 2a squared equals 31 on 6 minus 4 on 6. Therefore 2a squared equals, so 31 minus 4 is 27 on 6. Then if I just get myself a bit more room up here, we'd go to a squared equaling 27, and we divide both sides by 2, so we go to 12, and then we get that a is just equal to plus or minus the square root of 27 on 12. And now this is where I suspect some people may have lost the marks by not simplifying far enough. That is in fact plus or minus in the top into square root of 9 times the square root of 3 on the square root of 4 times the square root of 3. So as you can see, I'll get this and this to cancel, and my possible values at a are plus or minus. Square root of 9 gives me 3, square root of 4 gives me 2. So a is given by, the possible values of a is given by plus or minus 3 on 2, or 1.5.